Welcome to the Deep Dive. Today we're embarking on, well, a really unique journey. We're exploring something that shapes all of us, but often goes unexamined.
Yeah, the genetic story of a nation.
Exactly.
Yeah.
We're diving into the United States of America, and what researchers are saying is one of the most complex and dynamic genetic narratives in the modern world, really.
It's pretty remarkable. The U.S. gene pool isn't defined by just one single ancient lineage, not like you see in some other countries.
Right.
Instead, historians really emphasize it's this unprecedented blending, thousands of ancestral threads woven together.
Thousands, wow.
Yeah, from Native American roots stretching back, well, tens of thousands of years, actually,
Okay.
to waves of migration from, pretty much every inhabited continent over the last 4 centuries or so.
So the result is this kind of living map.
That's what scientists call it, yeah. A living, evolving DNA mosaic.
Okay, so let's try and unpack this. Our mission today is to figure out how this incredible genetic tapestry was actually woven, what it means for you, for science, and why it brings up some really big questions for society.
Definitely does.
So let's begin right at the start. The earliest chapters of this genetic story. What have scientists found out about the genetic signatures of the indigenous peoples?
Right, the first peoples.
Yeah, Native American, Alaska, Native Hawaiian groups. What do we know?
Well, what's really revealing here is that the evidence, both archaeological and genetic, points to human presence in North America going back as far as maybe 23,000 years ago.
23,000.
Yeah, with continuous settlement in some spots. And a key finding is that certain Native American populations have these unique mitochondrial DNA haplogroups.
Okay, mitochondrial DNA. That's
Yeah.
passed down from the mother. Yeah.
Exactly. It tells you about ancient maternal lineages. Specifically, we see A2, B2, C1, and D1, and these are markers you just don't find outside the Americas.
Really specific then.
Very specific. And we also see how Alaska Native and Inuit groups carry distinct genetic adaptations. Things like tolerance for extreme cold, high-fat diets.
Adaptations for the environment.
Right. Similar in some ways to other Arctic populations, say in Greenland, but, with their own unique variations, too.
It's fascinating how deep those roots go. But as profound as they are, the story really explodes in complexity later on, doesn't it?
Oh, absolutely.
With European colonization.
Uh-huh.
That marked a really dramatic and often, well, challenging new chapter.
Mm.
How did those first waves of European settlers start to reshape things genetically?
That's right. I mean, the genetic makeup of what's now the U.S. was fundamentally reshaped starting in the 16th, 17th centuries. You had settlers coming mainly from England, Spain, France, the Netherlands.
Okay.
And this is crucial, this blending wasn't always, voluntary.
Right. That's a critical point.
Absolutely. Think about the transatlantic slave trade. It forcibly brought over 12 million Africans to the Americas. About 400,000 arrived directly in what became the U.S.
400,000 directly.
And their descendants today number in the tens of millions. This profoundly shapes how we even talk about genetic heritage in this country. It really forces you to ask, what does heritage mean in this context?
Yeah, absolutely. And that evolution didn't stop there, did it? The story kept changing with later immigration waves.
Exactly. You see these big influxes. Ireland and Germany in the 19th century.
Right, the potato famine, other factors.
Then Southern and Eastern Europe, late 19th, early 20th century. And then more recently, late 20th, 21st century,
Right.
Significant migration from Latin America and Asia.
So it just kept adding layers.
Constantly adding layers. Today, something like nearly 14% of the U.S. population is foreign-born, and there are over 350 distinct ethnic ancestries represented.
350. That's incredible.
It really is. It's like a global cross-section, a snapshot of humanity almost.
So, okay, we have this incredible genetic variety, this global sampler idea. How does that actually benefit fields like medicine and genetics? What can we do here that maybe can't be done as easily elsewhere?
Well, that's the really interesting part for science. This huge genetic variety makes the U.S. a unique and incredibly valuable place for medical and genetic research.
How so?
Take the NIH's All of Us program, big initiative. They're aiming to get health and genetic data from 1 million people.
1 million? Wow.
Yeah, and it's specifically designed to understand how ancestry, lifestyle, and environment all interact to affect health. Because U.S. populations carry genetic variants specific versions of genes from almost every known human population group.
So you find everything in one place, basically.
Kind of, yeah. You find malaria resistance alleles common in people of African origin, lactose tolerance genes from European ancestors, certain Native American alleles linked to immune response. It's all here.
So it's not just a melting pot of cultures.
Exactly. It's like a living laboratory. It lets researchers study global human health patterns, disparities, maybe develop more universal medical solutions, all by looking within this one incredibly diverse population. It's a profound opportunity.
But this genetic wealth, this amazing resource, it comes with a really complicated history, doesn't it?
It absolutely does.
It wasn't all voluntary migration adding to this mix. There's a much more painful side to how this tapestry was woven.
Yes, that's undeniable. A lot of the genetic mixing in the U.S. is a direct result of forced migration, obviously slavery, the displacement of native populations, assimilation policies. Native American DNA research, for example, has a particularly fraught history. It's been controversial for a long time. Some tribes have refused to participate in research studies because of past abuses.
Abuses like what?
Well, like cases where genetic material, their DNA, was collected for one study but then used for completely different research without proper permission or consent. That understandably erodes trust.
Yeah, you can see why. And that brings up a huge question, right?
Yeah.
Who should actually control genetic data in a society this diverse?
That's the crux of a lot of debate right now.
We see these ongoing discussions about genetic privacy, especially because commercial DNA testing, companies like 23andMe, Ancestry DNA, it's so popular here, but the regulations around it are, well, maybe a bit light.
That's a concern many people have, and some of these companies have sold access to anonymized genetic data to pharmaceutical companies for research.
Which raises questions about consent again, doesn't it? And who really owns your data or your community's data?
Precisely. And it leads to the next question. How should the benefits of all this research be shared, especially with the communities whose DNA is enabling the discoveries?
Right.
And then there's another layer. Some critics bring up this idea of genetic nationalism.
Genetic nationalism, what does that mean?
It's the concern that ancestry test results could be misused, twisted to reinforce exclusionary or even racist ideas about who belongs, despite the clear scientific fact that the U.S. is fundamentally built on mixing and migration.
So using genetics to divide rather than show connections?
That's the worry, yeah. And it's important, we should be clear, these are viewpoints from critics, arguments being made in this debate. We're not endorsing them, just reporting on the concerns being raised.
Understood. It adds another layer of complexity to the whole picture.
Definitely.
Okay, just to give people a really concrete sense of how unique this is, how does the U.S. stack up globally?
Well, here's a striking comparison. If you look at the sheer number of distinct genetic lineages present in the population, the U.S. is right up there. It rivals places like Brazil for being one of the most genetically diverse countries on the entire planet.
Rivals Brazil. That's saying something.
It really is. And here's something else that's truly thought-provoking.
Yeah.
The average U.S. genome, just, the typical person's genetic makeup can carry ancestry, tracing back to 3 or more different continents.
3 or more. Even if someone identifies strongly with just one background.
Even then, it might be small percentages, remnants from generations ago, but genetically, the evidence of mixing is often there. It reveals this powerful truth, doesn't it? That beneath maybe our cultural labels or how we identify ourselves, our actual genetic tapestry is way more interconnected, far more complex than we often realize. It kind of fundamentally challenges any simple monolithic ideas about identity.
So wrapping this all up, what does this mean for you listening right now? Scientists have found this U.S. gene pool is, well, like nothing else.
Right.
It's this dynamic, constantly changing map of the human story.
Yeah, and it really forces us to ask some big questions, doesn't it? In a nation built on both voluntary and, crucially, involuntary migration, how do we even define genetic heritage? What does it mean here? And thinking about everything we've discussed, the scientific potential, the ethical issues, the history, should this incredibly rich genetic data be, freely shared with the world to push science forward?
Right.
Or does it need to be carefully protected to ensure the rights, the privacy, the identities of the individuals and the communities whose DNA actually tells this profound, complicated story?
It's such a complex tapestry, isn't it? Just layer upon layer.
It really is.
A living, evolving map of humanity itself. It really urges us to think about not just where we came from, individually or collectively,
Right.
but how our shared genetic story, with all its twists and turns, continues to shape our present and what it means for our future. Definitely something to ponder as you reflect on the genetic journey of this nation.